guys, hopefully that you're all doing well. So today for geometry, what we're going to be working with is we're going to be working with analyzing not only different types of triangles, we're going to be analyzing certain parts of triangles, and then we're going to be analyzing the sides to see if certain numbers can actually create and make triangles, right? So the first thing that we're going to look at, we're going to be looking at different types of triangles, right? So in geometry and in any other type of figure, whenever we're analyzing triangles by sides, we're always looking at three different types of triangles, right? We have ones that are called equilateral. We have others that are called isosceles. And then we have a last one that's called scalene, right? And I think that you guys have already worked with this in the past, especially in elementary school, but it's not bad to actually go over all it. So what an equilateral triangle is, whenever you guys have an equilateral triangle, all that means is that all three sides are all congruent. For an equilateral triangle, every single side has to be congruent. They all have to be the same. So if this is going to end up being, let's say, 4 meters, that'll be 4 meters, that'll be 4 meters. Literally, an equilateral triangle, all of its sides are all congruent, right? When it comes to an isosceles triangle, an isosceles is different just for the fact that instead of all the sides being congruent, now we're only going to have 2 sides. Any 2 sides can be congruent, right? In this case, I'll make the left and the right, right? So we put one tick mark to show that they're the same. And if I have just 2 sides that are congruent, automatically we know, again, let's say that's 5 inches, this would be 5 inches. We can even put 4 inches here just to show you guys that they're different. So whenever you have 2 sides that are congruent, that's considered an isosceles. What a scalene triangle is, whenever you guys have a scalene triangle, all that means is that every single side on the scalene is all different. So if they're all different, you'd have 1 tick mark there, you'd have 2 there, you can put 3 there. And again, it's just to show that every single side that we have is all completely different, right? That's what a scalene is. So when we're looking at it, if all the sides are congruent, it's equilateral, I'm sorry. If 2 sides are congruent, we know it's isosceles. And if all the sides are all different, if no sides are congruent, it's automatically scalene. So those are the 3 names of triangles that we have based on the side measures, right? And then from this, and again, just good review from the past, since they're all triangles, we know that all of the angles inside, interior, all add up to 180, right? So we've looked at all the triangles, right? We've analyzed it based on their sides. And now there are 2 parts of a triangle that we have. Something called the median, and then there's something that's called an altitude, right? One of these you may have heard of already in the past before. You may have heard of the word altitude, but we'll get to that. So medians and altitudes, they apply to triangles. I'm sorry, I was saying only, I was mistaken. When it comes to an altitude, when it comes to a median, they apply to triangles. They also apply, they can apply to other figures as well, but we're analyzing it through the eyes of triangles, right? Since we're just working with triangles right now. So if we look at this, right, we have 2 triangles that look basically the same. What a median is a median is a line that's inside of the triangle, and what we do is that it connects to the opposite midpoint. So what we want to do, what a midpoint is not only does it connect to the opposite midpoint, but whenever we're analyzing this, we know that for this to be a midpoint, it means it's in the middle of this side, right? So if this point is in the middle of this side, it means that this is equal to that, right? We know that this side here, this part, is going to be congruent to that part. And so we have that. And it's just to show you that that point is in the middle, that this is a midpoint, right? And we know that that's a midpoint because, again, if these 2 segments are congruent, automatically we know that point has to be in the middle. So what we know about a median connects to the opposite midpoint, right? Connects to the opposite midpoint. And that's what a median is. It literally connects to the opposite midpoint. So whenever we're talking about a median, it has to connect to the opposite midpoint, right? When we're talking about an altitude, Now altitude, you guys may know it as another word. You may know it as a height, right? When we're talking about the altitude of anything, it could be a room, it could be a house, it could be a car, it could be yourself. If you're talking about an altitude, we're always talking about the height of something. And the way that you measure the height of anything, you can't ever go crooked, right? So if I wanted to measure the height of this room, we would have to go perfectly straight up, right? Because again, if you're measuring something crooked, it's not a height. That's why whenever you're asked to measure your height, you're asked to stand straight. Because standing straight means now I can perfectly measure my height. So when we're talking about an altitude, what an altitude is, it's a line that has to go from the highest point to the base, right, to the bottom. But in order for us to know that this is an altitude, that line has to go straight, right? The only way that we know for a fact that a line goes straight is if it creates a right angle, right? Because once you have a right angle, automatically we know that that line is straight. So right now what we know is a median. A median always has to go to the midpoint. An altitude does not. What an altitude has to do, it has to be the highest point, it has to reach the highest point, but it also has to form a right angle, right? An altitude must reach the highest point from base, and form a right angle, and that right angle is extremely important because again, it may not seem like it, but that right angle is what tells us that this line is going straight. And if that line is going straight, automatically we know that that's the height, right? But again, be careful, because this is a height because it goes to the highest point. If I were to draw this right now, even though it has a right angle, that is not a height because it's not going all the way to the top. It'd be like me saying that I'm measuring my height, so I'm measuring my height from my feet to my elbow. Wouldn't make sense because even though it's straight, it has to go all the way to the top. So remember, the difference between the two, median goes to a midpoint, altitude goes to the highest point and forms the right angle, okay? And now looking at all these different parts of triangles, right? It's us getting comfortable with triangles, it's us going more in depth with triangles. We started off especially talking about equilateral, isosceles, scalene, analyzing sides. And now what we have is there's something else that's called a triangle inequality theorem. And again, it sounds complicated, but it's not. The triangle inequality theorem. Inequality theorem. Sorry if it gets a little tight over there at the bottom, at the side. Triangle inequality theorem. And it only applies, as said, to triangles, right? And what the triangle inequality theorem shows is it analyzes ways to tell if sides can actually make a triangle, right? So let's call this one, do it in a different color so you guys can actually focus on that. Let's call this one A, let's call this one B, let's call this one C. And what the triangle inequality says that whenever you add up any two sides of a triangle, it always must be greater than the third side. Any two that you add up must always be greater than the third. So for example, if I were to do A plus B, it must be greater than C, right? And again, it can't just be true just for one set. It has to be true for all of them, right? So when we add up A plus B, it has to be greater than C. If we were to add up A plus C, it has to be greater than B. And then one more that's missing. If we add up B and C, it has to be greater than A. And that's what the inequality theorem, the triangle inequality theorem states. It's that whenever we add up two sides of a triangle, it always has to be greater than the third. Because again, it's like saying this. Goal of a triangle. Sometimes people think that a triangle is just anything that has three sides. This here has three sides. That right there is not a triangle. And the reason that it's not a triangle, we can look at that, we can look at this one here. The reason that these aren't triangles is because this one doesn't close, this one is too long, if it becomes easier to see. It's almost like being given sides like this, where if you try to move this around, let's say I now were to take the side and say, you know what, I can bring it this way, but now If we get something like this, none of these are triangles, because the point of having a triangle is to be able to perfectly close that triangle. Triangle has to have 3 sides, but all the sides have to connect perfectly. So if it's open, not a triangle. If it's open and overlapping, not a triangle. If it closes, but one of the sides is still way too long, it's not a triangle, because the triangle has to connect perfectly. The one way we know that a triangle connects perfectly is if whenever we add 2 sides, always has to be greater than the third. And I'm going to show you that with numbers. But again, can't just be true once, has to be true all 3 times. Because if all 3 are true, it's a triangle. If one of those is wrong, if one of those isn't greater, then automatically we know it's not a triangle, because all of them have to be greater, all of them. If it's equal, it's not a triangle. Because again, sometimes people think that if it's equal, it's a triangle. No, it has to be greater. Okay? And again, if one of them is wrong, automatically we know that those sides can't make a triangle, right? And now I'm just going to show you how you actually use it. I'm going to give you 3 sides. So let's say that I have the sides 5, let's say I have the sides 5 centimeters, I had 6 centimeters, and I had 9 centimeters, right? Let's say I have those 3 sides, and I want to know if those sides can make a triangle, right? I want to know if those, and again, if it helps you to visualize, imagine having a triangle where this is 5, this is 6, and then this one here is 9. And I want to say, you know what? I want to see if those sides can make a triangle. The way that you do that, and I'm going to erase this here, just to not confuse you with a picture like that. The way that you're actually going to see if those can make a triangle perfectly is applying the triangle inequality theorem, which again, you're going to add up 2 sides and it has to be greater than the third. So, first one, and it doesn't matter the order, so it's like saying this. When we add 5 plus 6, it has to be greater than 9. And when we add up 5 plus 6, 5 plus 6 is greater than 9. 5 plus 6 is 11, 11 is greater than 9. So we know that that one's true, right? And again, even though the first one is right, we have to do it for all of them. So we added 5 plus 6. Now let's add 6 plus 9. So 6 plus 9 has to be greater than 5. Notice how we're always using different combinations, right? So when we add up 6 plus 9, that's 15. 15 is greater than 5. So we know that that's correct. And now the last one, we added 5 plus 6. We added 6 plus 9. Now let's add 5 plus 9. And we want that to be greater than 6, right? And when we add 5 plus 9, 5 plus 9 is 14. 14 is greater than 6. So we know that that's true. And so the fact that all 3 of those are true, automatically we know that, yes, those 3 sides can make a triangle. They will make a triangle. Because again, all 3 statements are true. Let's look at another one, just so you can actually see when it wouldn't be a triangle, right? Because it is important to see when it is. It's also important to see when it's not, just so you can actually tell the difference, right? Let's say I have the sides 7 feet, 3 feet, and 2 feet. Same thing. We have 3 sides. We want to know if they can make a triangle, right? By applying the triangle inequality theorem. Same thing. When we add up 2 sides, must be greater than the third. So the first one we can do is 7 plus 3. We want that to be greater than 2. 7 plus 3 is 10. We know that 10 is greater than 2, so that's good. Next one, 3 plus 2 has to be greater than 7. So when we look at it, 3 plus 2 is 5. Now here's our problem. 5 is not greater than 7. 5 is actually less than 7. Since 5 is not greater than 7, we know that this statement is false. The fact that that statement is false, we don't even have to do anything else. Because automatically, the second that one of them is wrong, we know that it's not a triangle. It won't be able to make a triangle. And the reason that it won't be able to make a triangle is if we took those 3 sides, it would never be able to close properly. So once we have that, we know it's not a triangle. Again, whenever you add up all the sides, it must be greater. If it's equal, it's not. Let's say that we have 5 over here, right? If I have 5 over there, 3 plus 2 is 5. 5 is not greater than 5, so it still would not be a triangle. Just always keep that in mind, guys. Whenever you add up 2 sides, it must be greater. And the last thing that I want to get to, we've seen now that if we have 3 sides, we can figure out if it makes a triangle. Now, let's say I gave you guys two sides, right? Let's say that I tell you that a triangle has two sides with 7 feet and 10 feet, right? So I'm saying I know a triangle. We know a triangle has 3 sides automatically. We know that this one, let's say, is 7. Let's say that this one here is 10. I want to figure out what this one can be. I want to figure out what this side can possibly be. I want to figure out all the measurements that this third side can be right there. And in order for us to figure that out, right? In order for us to figure out what that third side can possibly be, there is an easy way to figure that out. The way that we figure this out is by analyzing those two, 7 and 10. And what you would do to figure out the smallest that it can possibly start at, you would end up taking those two numbers and you would subtract them. 10 minus 7 gives us 3. To figure out the biggest that it can get to, you would take those two numbers and you would add them. 10 plus 7 gives us 17. And what we would now know is what the sides would be. All the sides that can represent this would be everything that's between this. It's not including those two, but it would be everything that's between those two numbers, right? Because the 3, we want everything that's going to be bigger than 3. We also want everything that's less than 17. We want everything that's between them. So our third side could be anything that's greater than 3 and everything that's less than 17, right? Everything that's greater than 3, everything that's less than 17. And that's all you would do, guys, to figure it out. You literally, to find the smallest it can be, you would subtract. To figure out the highest it can get to, you would add. And then it's everything between those, right? Again, it doesn't count those numbers because if we were to use 3, for example, 7 plus 3 is 10. 10 has to be greater than 10. That's why it couldn't be 3. But now if we were to take, let's say, 4, 4 is between those. 7 plus 4 is 11. 11 is greater than 10. That's why 4 would work. But again, that's how you figure it out. Always remember, guys, whenever we're trying the triangle inequality theorem, whenever we add up two sides, always must be greater than the third, and it can be true once, has to be true all the times. If you have any issues, feel free to ask. Take care.